So it can take a couple of hours to do each sample prep. And then the maps took 20 minutes in here, so it's, once you get set up, probably about an hour on the SEM. So you're looking at a decent amount of work for each sample. I did actually prepare 3 samples for this, but the third one was not as exciting. I thought it would be a very interesting polymer sample. It was part of an electrical cord, and I've looked at some in the past where they had a lot of different types of fillers in them as fire retardants. And this one was very boring. It only had calcium carbonate as fillers. So it turned out not to be really interesting. So I didn't include it in the slides. But I was able to do all 3 samples prepped and analyzed in basically a day. So it does take time, but it's not like days and days and days. So
when do you realize, I mean, other than that, like what you just described, because it didn't have much, at what point would you realize you had a sampling failure?
A sampling failure? Oh, you mean like when I was doing my process?
Yeah.
Well, if we go back, let's push the mouse here.
I don't mean this one with the materials. I mean more like if it breaks or something while you're doing.
Yeah, while I'm doing this part here.
Right. Yeah.
Well, these pictures were actually taken in the FIB instrument itself, so it is an imaging tool. So, because you have to be able to see what you're doing at very high mag, obviously, to manipulate these things. So, the problems that can occur is, for instance, when you're trying to glue the probe to that thing, and then to the little lamella, as it's called, and then you cut it free, and it flops over on its side because it wasn't really stuck. You thought it was stuck, but it wasn't really stuck, because it's hard to stick things when they're only a few microns across. Or sometimes, you'll get it up to this point, and so if it just falls over, you can usually still pick it up. And then, but if it falls off at this point, it might be gone, and you might have to start over. Yes, it might be consumed in analysis. The same thing can occur here. You can be doing the attach here to glue these 2 together, and then you cut the probe away, and it wasn't really stuck to the grid, and it falls off, and that's generally not recoverable. So hopefully you don't have a one in a million failure that you're analyzing in that point, or else you'd better find a way to recover it. So it is possible for problems to occur, which is, some of the time involved is that you go very slow and you try and make sure that everything's well adhered. And when you're, say for instance, you do glue it down very well, and then you're cutting the probe off before retracting it, you don't really cut the probe all the way through, you go to retract it, you're going to rip your sample apart. So, again, when manipulating things on the micron scale, there's definitely there's possibilities for failure. This first part usually goes flawlessly because it's standard cross-sectioning. It's all the micro manipulation that goes, could go badly. I won't say it goes badly. These all worked great.